So one of the limits that you will need to know and just need to memorize so you're able to use it is the limit as x approaches 0, sine of x over x. And you'll need to memorize that this equals 1. So this is something that you need to make a flashcard of so that you have it. The reason is that as you go through, you're going to just have to recognize when you see it in problems. And so you want it to be fresh in your mind that there is a set limit for sine of x over x as x approaches 0. Okay, see, because what happens if you try and solve this is it looks like it would be 0 over 0. And so anyway, so it has to be, you have to memorize that it equals 1. So we're going to go through and let me show you some examples of how you would use this. The first one would be in a situation where you have, well, you could just have sine of x over x, but then you're going to see stuff like this on your homework, where maybe it'll say the sine of x over 2x squared plus 3x. Okay, so when you go to solve this first with substitution, you would get the sine of 0, which is 0. And then you plug a 0 into the denominator, you'd also get 0. So we know that substitution doesn't work, so the next thing we move to is we try simplification. So we're going to take this, we're going to simplify our denominator. If you notice, in the denominator, there is a common factor of x. And so we can pull out an x, and we're left with 2x plus 3. Okay, so now you notice that you do have the sine of x over x. So the limit as x approaches 0 of the sine of x over x, and this is just multiplied by 1 over 2x plus 3. So I just separated this out using algebra. And we know from the laws of limits that we can take the limit of each of those separately. So the limit as x approaches 0 of sine x over x, from our flashcard, we know that this equals 1. And then we also know that when we substitute the 0 into here, that we get 1/3. So the limit would be 1 times 1/3, which is 1/3. Oops, sorry. Which equals 1/3. Okay, so sorry, that was just me accidentally hitting scroll. All right, so now another situation that you might see is if you had something like, let's take the limit as x approaches 0 of the sine of 5x over x. So when you first look at this, you think, okay, it's kind of, it looks close to sine x over x, but it's not quite right. If you do have sine of 5x over 5x, then you can still use the limit as 1. So what we can do is we can manipulate this to create the situation where it is the sine of 5x over x. The way that we would do that is we're going to take the limit as x approaches 0, and we're going to multiply, because we're going to multiply the top and the bottom by 5. So I'm going to multiply this by 5 and this by 5. Now what happens anytime you multiply by something like 5 over 5, which equals 1, you're multiplying by 1, and so you're not changing the value of it. So now we would just have 5 sine of 5x over 5x. Well, we can separate this out as well, so that we have the limit as x approaches 0 of 5 over 1 times the sine of 5x over 5x. Well, from our limits, we know that this equals 1, and the limit as x approaches 0 of 5 is 5. So we get 5 times 1. So the limit would equal 5.